Hi, this is Maggie. In this video we're going to talk about adding drag to moving objects. To illustrate what drag might look like, I'm going to run listing 9.7. This program simulates a pineapple in a pool floating in a pool. By pressing the arrow keys, the user can introduce some water jets at the top left, bottom, or right of the pool, which apply a force to the pool float. The program simulates the drag of the water in the pool by slowing the motion until it eventually stops. The equations for simulating the physics realistically are complicated, but we can introduce reasonably realistic-looking drag in a pretty simple way using a constant value that we multiply by our speed. We'll illustrate using listing 9.2, which is a simpler program. This is listing 9.2, and if we run it, we see it's a perpetually bouncing ball. We simulate the ball's motion by adding an x displacement and a y displacement to the ball's x-y location each time through the game loop. We check boundaries and change direction if the ball has reached a boundary, which is how we get the bouncing effect. I'll rename this program to drag.py. And we'll edit it so that the ball slows and stops, presumably because of some friction on the surface on which it's rolling. The easiest way to write the equation is to make drag the amount of the speed that is retained each time through a loop. So, like a percentage, drag will be a value between 0 and 1. The smaller the number, the faster the object will stop, because less of its speed is retained between loops. I'm going to annotate and initialize a variable called drag to the value 0.96. Now, down in the game loop, I'll multiply both dx and dy by drag before I add them to the x and y coordinates of the ball. And that's it. When we run the program now, the ball slows and stops. It stops a little awkwardly, so we might fix it by checking if dx and dy are below some threshold, and if so, we will just set them to 0. So I'm going to add, after I set the values of dx and dy, dx equals 0 if dx less than 0.5, else dx, and the same for dy. That's Python's version of the ternary operator. It allows me to write an expression that evaluates to one value or another based on the condition. So dx less than 0.5 is the condition, and the expression evaluates to 0 if that's true, and dx otherwise. So I'm assigning 0 to dx if the condition is true, and otherwise I'm assigning dx back to itself. So if we run that now, the stopping is a little smoother. And that's it. That's the easy way to add some friction or resistance to your motion. Add it in some of your programs and experiment with the constant value that you use. Have fun with it.